April 16th, 2026. I want you to just picture the device sitting in your pocket right now.
Yeah, your smartphone.
Right. Today, for this custom-tailored deep dive, we are looking at a single, incredibly dense AI news digest from that exact date in the near future.
It's a fascinating snapshot, honestly.
It really is. And what this digest reveals is the precise moment when artificial intelligence stopped being, just a math problem running in some distant air-conditioned data center.
Right, and it became a physical utility, like something seamlessly woven into the fabric of your daily life.
Exactly.
Because when you scan the 4 headlines in this digest, you see an update on neural network efficiency, a medical study in the ICU.
There's a shift in financial market tools, too.
Right, and even a debate in the fine art world.
Yeah.
And at first glance, they look like fractured, totally separate events.
Just totally random news items?
Yeah, but they actually describe a unified mechanical shift. I mean, we were looking at the timeline of how computational power is decentralizing.
And fundamentally altering how human beings make decisions.
Absolutely.
Okay, let's unpack this, because we cannot understand the applications in, say, healthcare or finance without understanding the bedrock physics of what is happening at MIT.
The hardware foundation is everything.
Right. So the digest leads with researchers developing an algorithm that dramatically improves the efficiency of neural networks. And the core issue here is the computational bottleneck, right?
Yeah, the energy demand. Historically, large language models and predictive algorithms require massive energy bandwidth. I mean, they consume gigawatts of power.
Just to maintain the constant matrix multiplications happening across billions of parameters.
Exactly. And the thermal limit of silicon is a real physical constraint. You cannot you can't just build bigger server farms indefinitely.
The global power grid literally cannot support it.
No, it can't. So what the MIT researchers have done is shift the approach from hardware brute force to algorithmic elegance.
Algorithmic elegance. I like that.
Right. Like, they didn't just build a bigger engine, they changed the combustion chemistry of the fuel. Yeah, they figured out how to dynamically route information through a neural network so that it only activates the specific pathways necessary for a given query.
Essentially pruning the computational tree in real time.
Exactly.
I look at it kind of like a sprawling city grid at midnight.
Okay, yeah.
Like the old models would illuminate every single street lamp in every single neighborhood just to guide one single car to its destination.
Right. Massively inefficient.
Yeah, but the MIT algorithm is a smart grid. It only turns on the lights immediately in front of the car. It leaves the rest of the metropolis completely powered down.
That's a great way to visualize it. And the downstream effect of reducing that computational weight is that you no longer need the massive data center for every little thing.
You can just run it locally.
Right. You can run a sophisticated parameter-heavy model locally on a smartphone or, smart home hub.
Without vaporizing the device's battery in 10 minutes.
Yeah, exactly. But what's really fascinating here is the tension between the consumer benefit and the structural necessity.
What do you mean by that?
Well, on a consumer level, local inference means zero latency. Your virtual assistant doesn't pause to ping a server in Nevada anymore.
It just responds instantly.
Right. But the underlying catalyst for this research wasn't actually to make your phone snappier. It was a response to an impending climate crisis driven by tech infrastructure.
Okay, I have to challenge the framing on that, though.
Go for it.
I understand the environmental benefit of reducing the carbon footprint of global compute, obviously, but is the green narrative actually driving the adoption?
You don't think it is?
Historically, behavioral shifts at a societal level are driven almost entirely by human convenience, and economic friction, not really ecological altruism.
Well, if we connect this to the bigger picture, the environmental impact and the economic friction are actually the exact same metric in this specific industry.
Oh, because energy costs money?
Exactly. The cost of electricity and cooling is the single largest operational expense for running these models.
So by aggressively shrinking the energy requirement.
The MIT algorithm lowers the financial barrier to deployment. The environmental sustainability is just what allows the technology to scale globally without regulators stepping in to cap energy usage.
That makes a lot of sense.
It transitions AI from being a resource-heavy luxury to an accessible, localized utility.
And that localization changes the fundamental physics of where algorithms can live. Because when you untether the processing power from the cloud, you eliminate the latency of data transmission.
Which is crucial.
Right. And that matters because there are environments where milliseconds dictate survival.
Absolutely.
Which means we are moving from the engineering labs at MIT directly into the intensive care unit.
Yeah, that's the next headline.
The second piece of this digest is a study published in Nature Medicine detailing a highly advanced AI system designed to analyze patient data natively right there in the ICU.
And, I mean, the intensive care unit is essentially the most gated, dense environment a human being will ever occupy.
Oh, without a doubt.
You have a patient connected to continuous telemetry.
Yeah.
You're looking at heart rate variability, blood oxygen saturation, respiratory dynamics,
Blood intake.
real-time pharmacological reactions. It's a massive stream of numbers.
And the human cognitive limit is the real bottleneck here.
Yeah, humans can only process so much at once.
Right. There is a psychological concept called Miller's Law, which states the average human can only hold about 7 distinct pieces of information in their working memory at any given time.
7. That's it.
Yeah. So even the most brilliant, highly trained ICU physician cannot continuously cross-reference 40 different fluctuating variables.
Across a 72-hour timeline, no less.
Exactly. And instantly recognize some microscopic statistical anomaly. It's just beyond human capability.
Right, because the human brain relies on threshold alerts.
Like an alarm going off.
Exactly. A monitor alarms when blood pressure drops below a defined safety line. But the AI system detailed in the study operates on multidimensional anomaly detection.
So it doesn't just wait for the alarm to sound?
No, it doesn't wait for a threshold to be crossed. It analyzes the subtle, high-dimensional interplay of all 40 variables simultaneously.
Wow.
It notices that, say, a 2% drop in oxygen combined with a barely perceptible increase in respiratory rate.
And maybe a specific enzyme level from a lab result 3 hours ago?
Yes, exactly. It sees that specific combination as the exact statistical signature of a cascading organ failure.
One that won't physically manifest for another 2 hours.
Precisely.
Here's where it gets really interesting. Because we are talking about a complete inversion of how critical care operates.
Completely.
We are shifting from reactive intervention to predictive stabilization.
Which changes the doctor's entire role.
Right. The doctor is no longer running into the room to treat a crisis that is actively happening.
The AI is providing a highly personalized, calculated forecast.
Allowing the medical team to preempt the complication entirely. They alter the fluid levels or change the medication before the patient's body ever actually experiences the crash.
It acts as a temporal lens.
A temporal lens. That's good.
Yeah, it provides the physician with the ability to see the immediate future of that specific biological system based on the historical data of millions of previous ICU cases.
Which is incredible.
It is. The algorithm handles the brutal math of time series forecasting, while the physician applies the contextual judgment of how to actually intervene.
And that mechanism, analyzing an avalanche of time series data to locate hidden patterns and forecast complex outcomes,
Yeah.
that's not isolated to biology.
Not at all.
When we look at the third section of the digest, that exact same predictive architecture is being aimed at the global financial markets.
Right. The variables just change from blood pressure and oxygen to supply chain logistics, interest rates, and consumer sentiment.
Exactly. Now, the financial sector has always utilized algorithmic trading. That's not new.
No, quants have been around for decades.
Right. But the digest highlights a structural inflection point here. AI-driven trading systems are now consistently outperforming traditional human-managed investment methods.
By adapting to market fluctuations in real time, yeah.
But the disruption isn't just the existence of the technology, it's the distribution.
This is key. The sophisticated predictive models that previously required, like a dedicated floor of quantitative analysts at a massive institutional bank.
Right, the big Wall Street players.
Those models have been optimized, partially due to the efficiency breakthroughs we discussed earlier at MIT.
And democratized.
Exactly.
They are now integrated directly into the retail platforms used by everyday investors. So, you listening to this deep dive, managing your own retirement account.
You suddenly have access to the exact same analytical horsepower as a Wall Street hedge fund.
But this presents a massive logical paradox, doesn't it?
How so?
Well, the entire concept of the stock market is built on informational asymmetry.
Someone knows something someone else doesn't.
Right. You make a profit because you know something or you have calculated something that the person on the other side of the trade hasn't.
Okay, I see where you're going.
So, if every single participant in the market, from the mega bank down to the retail investor, is utilizing the exact same perfectly optimized AI to predict that a stock will increase in value,
Yeah.
who takes the other side of the trade? Doesn't the competitive advantage immediately cancel itself out and just freeze the entire market?
This raises an important question, really, about the definition of advantage in a hyper-efficient system.
Because it seems like it would just break the market.
You'd think so.
Yeah.
But the financial ecosystem doesn't freeze. The baseline of operations simply shifts.
Shifts how?
Think of it like the introduction of the spreadsheet.
Okay.
When only a few accountants had spreadsheet software, they had a massive speed advantage over those using pen and paper.
Sure, they could do the math 1,000 times faster.
Right. But when everyone adopted the spreadsheet, accounting didn't stop.
True.
The baseline expectation of speed just changed. In a market where predictive capability is a universally distributed utility, the generation of alpha.
The ability to beat the market average.
Exactly. The generation of alpha moves away from the pure speed of data processing.
Oh, I see. The advantage moves to the architecture of the human goal.
Precisely.
Because if the AI is a flawless execution engine, the differentiator becomes the parameters you actually feed it.
Yeah, the human intent.
Right. Like, the retail investor might prompt their AI to optimize for long-term dividend growth while strictly avoiding companies with poor environmental records.
While a hedge fund might prompt their AI to exploit micro-volatility in emerging market currencies over a tiny 24-hour window.
The math is equally perfect in both scenarios.
Exactly.
But the human philosophies driving the algorithms are fundamentally different, and that is what creates the market liquidity.
We are stripping away the old mythology of Wall Street.
The intuition of the genius trader relying on a gut feeling.
Yeah, that's gone. We're replacing it with brutal mathematical probability. The human is no longer the calculator.
The human is the navigator setting the destination.
Well said.
Setting the destination. Which brings us to the final and arguably most complex frontier in this digest.
The art world.
Yeah, because we have watched these efficient, localized models conquer the objective realities of hardware constraints, biological failure, and market efficiency.
All very math-heavy objective fields.
Right. But this final headline forces this perfectly logical predictive engine into the deeply subjective, emotionally driven realm of the art gallery.
It's a huge shift. The digest notes a surging trend of major, established fine art galleries exhibiting pieces generated entirely by algorithm.
Which has caused quite a stir.
Oh, it has catalyzed an intense philosophical debate within the critic community regarding the very nature of creativity.
The tension really lies between the concepts of replication and creation.
Exactly.
So what does this all mean? The mechanics of generative AI dictate that it must be trained on existing data.
Right. It can't conjure something out of absolute nothingness.
It ingests millions of images of human art, from Renaissance oil paintings to modern digital conceptualism.
And it mathematically maps the relationships between lighting, texture, geometry, and color.
So when a human inputs a prompt, the AI just navigates that massive mathematical space to predict the most accurate arrangement of pixels to fulfill the request.
And that's where the replication argument comes in. It hinges on the fact that the algorithm possesses no lived experience.
No emotion.
Right. It has no understanding of mortality, no grief, no joy. Therefore, it lacks intent.
So the critics argue it is just performing a highly complex parlor trick.
A trick of statistical probability, yeah. Essentially creating a hyper-sophisticated collage of human history without adding any genuine emotional truth.
It is the ultimate automated tool, but a tool nonetheless.
Exactly. That's the critical view.
But the counter-argument is that human creativity operates on a strikingly similar mechanism of synthesis, doesn't it?
Also.
Every painter who has ever lived was influenced by the visual data they ingested throughout their lives.
That's true.
They study the masters, they absorb the world around them, and their brain synthesizes those inputs to produce something novel.
So you're saying the AI is doing the same thing?
Kind of. I mean, if an algorithmic system can synthesize human art history to generate an entirely new image that provokes a visceral, emotional reaction in the human viewing it.
The origin of the pixels almost becomes irrelevant to the experience of the art.
Exactly.
It challenges the core definition of authorship.
It really does.
Because if an artist in 2026 is no longer manipulating physical paint, but is instead meticulously curating language to navigate an AI's latent space.
Adjusting the prompt dozens of times.
Right, adjusting it to extract the precise visual representation of an idea in their head. They are acting as an architect of intent.
I love that phrase, architect of intent.
Yeah, the labor of execution is outsourced to the machine, but the curation of the concept remains entirely human.
And the economics of the gallery space reflect this shift perfectly.
Oh, absolutely.
Because in a world where an algorithm can generate a technically flawless, hyper-realistic masterpiece in 4 seconds at zero cost.
Technical execution is no longer a scarce commodity.
Right. Abundance destroys the value of mere execution.
That's what becomes valuable.
The scarcity. And therefore, the value shifts to the human taste required to select that specific output from an infinite sea of possibilities.
That's a profound way to look at it.
The art is no longer just the image itself. The art is the decision to claim the image.
It really is a cohesive narrative of structural integration when you step back and look at all 4 of these pieces.
It is.
I mean, from the physical hardware breakthrough at MIT,
Yeah.
redefining our energy consumption,
To the predictive models, altering the temporal reality of the ICU.
the democratization of quantitative finance.
And the redefinition of creative authorship. We are literally watching the architecture of society adapt to a world where hyper-efficient optimization is the new baseline.
We really are.
But stepping back from the immediate facts of this 2026 digest, there is a broader consequence to this level of integration.
What are you thinking?
We are building a world that aggressively attempts to engineer friction out of the human experience.
Yeah, completely.
We are optimizing for the perfect medical intervention, the perfect financial trade, the perfect visual aesthetic.
Which leaves us with a lingering, somewhat uncomfortable implication to consider.
Yeah.
If algorithms are universally optimizing our systems to be flawlessly predictive and mathematically ideal.
What happens to the inherent value of the human mistake?
Exactly. The flaw, the deviation from the mean.
Huh.
As efficiency and perfection become the invisible background radiation of our daily lives, there may be a profound psychological backlash.
We might actually start to push back against it.
We might witness a future where society actively begins to crave human error and unpredictability.
Just to feel something real.
Simply because that friction, that chaotic deviation from the algorithmic ideal, is the only thing that proves a system is still human.
Imperfection might become the ultimate luxury good.
Exactly.
A friction is the fingerprint.
I like that.
That is a powerful lens through which to view the technology you interact with today. And we are going to leave you to dissect that idea on your own.
There's a lot to chew on.
It really is. Thank you for joining us on this deep dive into the architecture of tomorrow. Keep questioning the systems designed to optimize your life. Stay endlessly curious, and we will catch you on the next deep dive.